All right, folks, so we got the notes for trigonometric word problems. So here's our steps. Draw and label a right triangle. You'll be given a side and an angle. The second side is what you'll be typically solving for. Determine which of the basic trig functions, sine, cosine, or tangent, uses the side you know and the side you want to solve. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So depending on which one of those which pair you have, tells you which of those to use. A calculator will be decimal, and then we solve. So here we go. Charlotte wants to use a fiberboard 34 inches long to create a skateboard ramp with a 20-degree angle of elevation from the ground. How high will the ramp rise from the ground at its highest end? Round your answer to the nearest tenth. So we'll draw our triangle. So 34 inches is how long the ramp is. So it goes on the hypotenuse. Our angle is 20 degrees, and we want to know how high is that. So from 20 degrees, this side is my opposite, that is my hypotenuse, so I have a sine problem. So the sine of my angle is the opposite over the hypotenuse. So to get x by itself, we have to multiply both sides by 34. So 34 sine 20 is equal to x, and this is where we go to our calculator to do the evaluation. So 20 times sine, whoops, nope, the other way, 34 times sine 20 gives us 11 point, calculator says, and we can see it, 628, but we need to round to the nearest tenth, so 0.6 would be our answer. Okay, Miguel's flying a kite, holding his hands a distance of 3.5 feet above the ground, is letting all the kite string play out. He measures the angle of elevation of the kite to be 25 degrees. The string to the kite, his hand, is 150 feet long. How many feet above ground? So similar problem. So there's our triangle. We have 150 feet played out, x, and our angle is 25 degrees. So just like the previous one, this is sine again. So sine 25, because we have the opposite in the hypotenuse. So multiply both sides by 150. So 150 sine 25 is equal to x. Go to our calculator. So nearest tenth, so 63.4. However, that's not the answer because we did miss something. Holding his hands a distance of 3.5 feet above the ground. So this horizontal line here is not actually on the ground. It's where his hands are. So if you want to think about, so that distance is 3.5. So the total height that the kite is above ground is the height above his hands plus how far his hands are above the ground. So the correct answer is actually 66.9. You typically, if you're given something like this above ground, you're going to need to add that number onto your height at the end. Okay, so for number 3, lead a 30-foot ladder against the wall, so it forms an angle of 76 degrees. So we'll draw our triangle. Our ladder is leaning against the wall, angle of 78 degrees. What's the horizontal distance? So horizontal runs left and right. So this one's not sine anymore because from 78 we do not have the opposite. We have the adjacent in the hypotenuse. So this one is cosine. So multiply both sides by 30. So x is 30 cosine. 78 would give me its nearest hundredth. So 6.24 if you round to the nearest hundredth. Okay, so 4 and 5 here are a little bit different. They're going to involve 2 triangles. So a boat heading out to sea starts at point A, which is 1,357 feet from a lighthouse. From that point, the boat's crew measures the angle of elevation to be 9 degrees. Sometime later, the crew measures the angle of elevation to be 3 degrees. Find the distance from A to B. So because this angle is smaller, it's going to be farther away because you have to look up less. So what's really happening here is we have, looks like this. So we know that this piece is 157, so like that's point A, that's point B. This angle is 9 degrees and that angle is 3 degrees. So what's actually asking us to find is that chunk right there. But what we actually have is we have 2 triangles. We have this one with 3 degrees, and we have this one, 1357, with 9 degrees. Now the trick for this problem is that we can't do anything with this triangle yet because we don't have any sides. But because they're looking at the same lighthouse, this height here is the same as that height there. So if I can work out how tall the lighthouse is, I can carry it over to this side here. So this triangle is tangent, opposite, and adjacent. So tangent 9 degrees equals opposite over adjacent. So multiply both sides by 1357. So 1357 times the tangent of 9 is equal to x. So that lighthouse is 357 times tan 9, 214.93. Just as a note, because it says here to round in there is tenth, I'm going to carry one extra decimal place, just not make sure I don't mess up my rounding. So since this says tenths, I went to hundredths. So that lets me replace this x with 214.93. And now I can work out what that side is. So still tangent, so tangent 3 degrees, opposite over adjacent. So now when we multiply by the bottom of the fraction though, that doesn't actually get us our x by itself. So we actually need to divide the tangent back across. So x is 214.93 divided by tangent 3. Another thing to be helpful is instead of writing this decimal down, if I notice I haven't used my calculator, so it's still there on my screen, so I can just use the answer command, which is usually there's a button down at the bottom where you hit shift negative. It'll let you pull your previous answer, or if you need to, just press divide, and it'll pull the previous answer, and then divide by tan 3. So that gives us 4101.06. Once again, I'm carrying an extra decimal place. Now, that's not my answer, though. Still, find the distance from A to B. So they started 1357 away. They ended up 4101.06. So they traveled the difference between those two numbers. So how far they moved is the difference. So then minus 1357. So 2744.1 would be your final answer. All right, number 5. So let's see here. She stands at a horizontal distance 21 meters from the building. Eyes to the roof is 24 degrees. Eyes to the top of the antenna is 42 degrees. So in this case, our two triangles share that bottom side. They both have 21. One of them, though, has a 42 degree angle, and the other one has a 24 degree angle. So we're looking for, once again, that piece there. So if I know how tall it is, if I look from the ground to the top of the antenna, ground to the bottom of the antenna, the difference between these two heights is how tall the antenna is. So this one is tangent. So the tangent of my angle is opposite over adjacent. Same thing over here, opposite over adjacent. Multiply everybody by 21 in both cases. So 21 tan 42 equals h to the top of the antenna. 2124 equals h to the bottom of the antenna. So the top of the antenna is 18.91 feet, meters, whatever it is. 21 tan 24, 9.35 meters above ground. So the antenna is the difference in those two numbers. 18.91 minus 9.35, rounded to the nearest tenth, 9.6 meters tall. So that's the end of our section.